Okay, for this next section, we're going to look at the angle-angle similarity postulate, or AA similarity. If you remember from your definitions, all we have to have is two sets of corresponding angles to be congruent in order to show that two triangles are similar. Remember again, similar means the same shape but not the same size. So if we look at this, we can see that angle C is 26, angle H is 64, and then we have angles D and G are both 90. So right now we have angle D congruent to angle G, but we don't know about K and we don't know about E. So you can do this one of two ways. You can find angle E or you can find angle K. I'm going to find angle E. We know that the measure of angle C plus the measure of angle E equals 90 degrees in this case, because there's 90 here. That would give us 26 plus the measure of angle E is equal to 90 degrees. We're going to subtract out 26 from both sides. If we do that, the measure of angle E is going to be 64. And since this angle is 64, we know this is going to be 26, we can state that angle E is congruent to angle H. Remember, to write a similarity statement, we have to go around in the same order. So we can say triangle CDE, and then the similar symbol is this squiggly line, CDE, and that matches with triangle KGH because we're going along the long leg, short leg, hypotenuse. So the long leg, short leg, hypotenuse. And the reason here would be by angle-angle triangle similarity. Okay? So again, we know the right angles are congruent, and they did angle E and angle H congruent. Therefore, the two triangles are congruent by angle-angle similarity. Alright, here's another example. Best thing for you to do in this case is to draw the two triangles separately. So we have a triangle that goes from here to here, here to here, here to here, and so I'm going to take this triangle and bring it over here, and that is triangle, that's triangle ABE. And we know this is 52 degrees. Sorry, that's a horrible E. Let's try that again. And then the second triangle goes from here to here, here to here, and up to here. Drag that over. And this is triangle ACD. We know this is 52 degrees as well. If we look carefully, angle A here is congruent to angle A because it's on both triangles. Therefore, we have two sets of triangles, or two sets of angles that are congruent. We can say angle A is congruent to angle A by the reflexive property. We can say angle B. Actually, we can't say angle B because there's a bunch of different B's. So we'll call it angle ABE. And then the second one we can just call angle C. And that's because it's given. So now we can say triangle ABE is similar to triangle ACD by angle-angle triangle similarity. Okay? And again, draw the triangle separately so you can see that. For the second one, there's a bunch of different ways you could go about doing it. I can look at these two angles right here and say those are vertical angles. So we could say angle SVR is congruent to angle TVU we could also say that that angle in this angle are congruent, or we could have said R and T. So I'm going to say angle S congruent to angle U, and that's by alternate interior angles. So triangle SVR is similar to triangle, let's see, if we say SVR, we have to say UVT, because the S and the U match up. And again, this would be by angle, triangle, similarity. Make sure you state why each part is what it is. So for example, this would be vertical angles congruent, and this one would be alternate interior angles. Okay? And going back to the last one, I should have done that one as well. This is reflexive property. And this one was given. So write the reasons as well. Alright, so for the first one again, if you draw them separately, we know those angles are 52, and so those are congruent, and reflexive property for angle A congruent to angle A, so those two triangles are similar. For the second one, we know vertical angles are congruent. We also know that S and U are congruent by alternate interior angles, because those lines are parallel. So the two triangles are are similar by angle similarity. Okay. In this problem it says, what if these weren't parallel? Would they still be similar? Well, if we go back, it's saying if this line and this line weren't parallel, could they still be similar? Yes, they could be, if instead of these being congruent, we could have, for example, those being congruent. If those two were congruent and these two were congruent, then the two triangles would be similar. Okay? So again, if S and T or if R and U were congruent, that would work as well. We want to know if these triangles are similar. Well, this is actually marked incorrectly, because if this is equiangular and this is equiangular, then this should actually be just one marking here. Or actually, let's do it this way. There should be two markings here, here, and here, because all of these angles would be 60. So we could say angle G is congruent to angle R, and angle F is congruent to angle Q. So therefore, and that's because it's given. And so the two triangles, remember, a similarity statement is writing triangle blah 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 is similar to triangle blah blah blah. So we could call it F, G, H, and it really doesn't matter the order for the second one in this case, because they're all congruent angles, but we'll call it, let's see, FGH, we'll call it QRS. They called it something different, but that's fine. Okay, FGH, QRS. And here's another one like the first example I showed you. Right now, the only ones we know are congruent. We know angle DFC is congruent to angle DFE, because perpendicular lines form right angles. Okay, and we want to find this angle right here, I guess, or we could find this one. I'm going to find this one right here. We can say that the measure of angle C plus the measure of angle CDF equals 90. We know the measure of angle C is 32 plus the measure of angle CDF equals 90. We're going to subtract 32. those go. The measure of angle CDF is equal to 58. And now we know that the measure of angle CDF, since this is 58 up here, degrees, CDF is equal to the measure of angle E on the other one. So we have our angle, and we would state that triangle, let's go up there real quick. All right. If we call this CDF, that's going to be similar to triangle. Remember, this will be 32 now, since these two angles match up with these two angles. So CDF and DEF, because we go hypotenuse short side. So hypotenuse short side by angle, angle, triangle, similarity. Okay? So there you go. And we're done. Thanks.